Okay, so we are doing inverse trig functions. So we know a lot of trig information already, and so now we're going to apply it in a different way. But before we do that, what we want to do is we want to go and review some of the things that we did in chapter 6. So remember in chapter 6, we did counting radians using the unit circle. Well, you still have to do that, and it's much easier to do. So we're going to be counting by pi's over 6 and pi's over 3s. If you know how to count them, then this won't be that difficult, what we're going to do next. So let's do the first one here, counting by pi's over 6 and pi's over 3s. That one is always going to be counting by pi's over 6, and then pi's over 3s comes along for the ride. So when we start here, remember our standard position angle will always start at, we're always going to have the origin, and we're always going to start right here at the positive x-axis, and then that is going to rotate around the circle on here and make some stops along the way. When we count pi over 6, pi over 6 is equivalent to 30 degrees, so we say that at start it's going to be 0 pi's over 6, here is going to be 1 pi over 6, and then the 45s are their own independent one. So we skip it and we go to 2 pi over 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then back to 12. So if you notice, we skip the 45-degree angles because those are not any way divisible by pi's over 6, but we did include the quadrantal angles, which are the angles on the x-axis and the y-axis. And mainly because if I do 3 pi over 6 here, that's going to give me, when I reduce it, it's going to give me the pi over 2. So every one of them, if you do the pi over 6, like for example here, the 2 pi over 6, that one there is pi over 3. So as I said, the pi over 3 comes along for the ride when it's going to pi over 6. And that way, you know where the angle is going to fall in, what quadrant it is, and then how to use your left-hand rule to actually find the trig ratio that belongs to it, given the trig function. All right, so now let's look at this one here, counting by pi's over 4s. Well, if you're an expert at pi's over 6 and pi's over 3s, then you are going to be an expert at pi's over 4s. And that one's really pretty easy on there. We start again, the x-axis. So we start there at 0, and now we're going to skip the pi's over 4s, and we're going to do the pi's over 1. So that's going to be 1 pi over 4, 2, 3, 4, 5, 6, 7, and then 8. So notice this one here is going to be 8 pi over 4, which ends up being 2 pi. And don't forget over here the same thing. This is 12 pi over 6, which ends up being 2 pi. They will always reduce, as well as this one here being pi over 4, and that's going to be pi over 2. So they always have to reduce to what the angles were given. So we know that the y-axis right here, this point is always going to be an angle made of, when I rotate it this way, it's going to be pi over 2. Okay, so now how could I count by pi's over 2s? Well, that's the same way. So we could start counting the pi's over 2s the same way that we did before. So we start here at 0, and then that's 1 pi over 2, 2 pi over 2, which is just pi, 3 pi over 2, and then 4 pi over 2, which is 4 pi, 2 pi. So counting by pi's over 2s, that's pretty easy as well too. Okay, and then here, that's what we're going to use. So what quadrant are the following in, and what is the sign on there? Remember, we do all students take CAT. So again, we do all trig functions are positive here. Students represents S for sine and cosecant. Those are the only two that are positive. Everything else is negative. Takes T for tangent and cotangent. Those two are positive in quadrant 3. Everything else is there. And CAT, college algebra trig, or calculus, whichever one you like. Or regular cats, if you're a fan of cats. Anyway, C is for cosine and secant, and so therefore those are the only two that are positive. Everything else is negative. So when you do that, then you could actually do these really easily. So this is 11 pi over 6. So all I need to do is count. But 11 pi over 6 is just one off of the 12 pi over 6. So I know it's going to be in the fourth quadrant. So we know it's going to be quadrant 4. And the sign of it is cosine is positive there, so we know that we're going to get a positive sign there. 7 pi over 3. Notice how it's a 3 that rides along with the pi's over 6's. So we need to change it to pi over 6's. So that means that I'm going to multiply this by 2, not 6, 2 to make it 6. And so we get 6 there. And so it's 14 pi over 6. So we go back and we count. Well, we know one surround is going to be 12. And then we need to go to 14. So that's going to be 13, 14. So this here is going to be 14 pi over 6, which is the same as 7 pi over 3. So it's equivalent to pi over 3. So that falls in quadrant 1. It's just when one's around completely. And so the sign is going to be positive because it's quadrant 1 on there. So it falls right there at the equivalent of pi over 3 is equivalent to 7 pi over 3. It just went once. It has the same trig ratios is what we're saying there. And same reference angle as well. So in this case here, this is what we say quadrant 1, and it's going to be positive as well. Okay, cotangent of 5 pi over 2. Again, 5 pi over 2, it's divisible by 2, so we're going to need to count there. So when we're counting here, here's the pi's over 2, so I am going to do that in this color. So we're going to have, this is 4 pi over 2, and so this one here is going to be 5 pi over 2, which is the same thing as pi over 2, the same reference angles and the same everything. Now this here, what happens is that it's a quadrantal angle, so we need to know it's cotangent. So what is the cotangent of 90 degrees? And so we end up having the cotangent is the same as the sine, the cosine, not the sine, the cosine of 5 pi over 2 over the sine of 5 pi over 2. And so we just care whether the sign is going to be a number. We know that the cosine is going to be 0, and then this here is going to be a number. So this here is going to be 0, because 0 divided by 4. The quadrantal angles, also if you do the left-hand rule, you get 0 divided by 4, or the square root of, you end up having, if you do that, you're going to have 0 divided by a number again, and that's what you're going to get. Anyway, so that's what we're going to get on there. Even if you do it using your left-hand rule, you'll still get the same answer. So your answer there is going to be 0. Okay, so that's a review of counting and being able to do that. Now, here, this is another thing you need to remember. Remember when we did this is all back from 6.5, when we had to analyze whether the trig functions were one-to-one, and we said that they weren't one-to-one because while they do pass the vertical line test, they do not pass the horizontal line test. So if you look at them, they're going to cross many times. They could only cross once in order to pass. So in order for us to do that, what we did is we shaded it along. And so once you shaded along there, so we know that this whole thing is shaded there. And if I were to just look on there, and if I were to do the horizontal line test just within there, it passes both the vertical and the horizontal line test, right? So it only crosses it once. So it's not going to go anywhere else, and it just crosses it once. So they were restricted this way, and so that we know that they're going to be one-to-one in that restriction. So when we do the inverse, so if we do sine inverse of x or cosine inverse on there, they will only be able to fall within this area that we restricted. And so where were they restricted? Well, here's where it shows us between negative 90 and 90. And so it was quadrant 1 and quadrant negative 1, or quadrant 4 if you want to look at it, quadrant 1 and quadrant 2 for these. And what happens is that sine, cosecant, so here sine, cosecant, so these all go together. So this is sine, cosecant, and tangent all have the same restrictions, and cosine, secant, and cosecant, they are all restricted over the same thing. So this one here is quadrant 1, quadrant negative 1. This one here is quadrant 1 and quadrant 2. And so